Hi, welcome to lesson 3 of unit 4. Today we have 3 learning goals: Pythagoras theorem, unit conversion with an SI system, and the perimeter of 2D shapes. Now you may be familiar with all 3, but just don't kind of slack off. Definitely try out the questions and try to take notes, and please be diligent because this is the first step into building more complex problems, okay? Right, let's get on with the Pythagoras theorem, or as they call it in Greece, the Pythagoras theorem. And Pythagoras lived somewhere in 500 BC, and probably others were also had discovered this, but this is the earliest record we have. And this theorem only applies to 90-degree triangles or right triangles. And we have the hypotenuse, which is the side opposite to 90 degrees. And that side is usually labeled C. So C squared is equal to A squared plus B squared. It could be called anything. It's just C, A, B are just labels for different sides. And the other two sides, which are non-hypotenuse, or the other two sides of the triangle, are called the legs of the triangle, okay? And as you can see from the diagram to the right, if you arrange the triangle A, B, and C, that's kind of one of the proofs that A squared plus B squared will be equal to C squared. It actually turns out that the areas of A squared, the areas of the first and the second square will be equal to the area of the third square, okay? Right, that is all there is to the introduction of the theorem. And let's get into some questions. Here we have a quadrilateral where two of the sides are equal, and we have a diagonal AC and we're going to find the length of the diagonal AC. Okay, so that's what we're trying to find. So X happens to be the hypotenuse, right? So that's the hypotenuse. So we have X squared is 12 squared plus 12 squared. Now just be careful with algebra. Please don't write this as 24 squared, because that's not correct. X squared is 144 plus 144, just 288. Normally, when you take the square root, you have to introduce plus or minus. Okay, kind of might look strange that I'm putting plus or minus here, but normally there's a plus or minus. We reject the negative solution. Okay, so that's, we reject that because the side cannot be negative. So X is equal to positive square root of 288, and that's in centimeters. And that is called an exact value. It's called an exact value because it's not rounded. It's not a decimal value that we have rounded. And if you put root 288 into your calculator, it turns out to be 16.97056, and so on and so forth, etc. So if you round this to 2 or 3 or 4 significant figures, it's still going to be a rounded value. For instance, I could write it as X is equal to 16.97. Okay, so that's 4 significant figures. Okay, so 4 significant figures. It's still a rounded value. Okay, so if you wanted to write an exact value, it would be square root of 288. Feel free to pause the video and try this out. 8 is the hypotenuse. I want to find this. I'm going to label this X. We have 8 squared, 6 squared plus X squared. 64 is 36 plus X squared. X squared is 64, take away 36. X is equal to root of 14, take away 6, 8. 5, take away 3, 2, root 28. Okay, so that's the exact value. Okay, so that completes the first learning goal, really. Second learning goal is unit conversions. And we're only going to look at SI unit conversions. There may be conversions in non-SI units, and in that case, we'll give you the conversion, okay? So you don't have to remember how many inches to a centimeter or how many feet to a meter and stuff like that. But SI unit, you have to know this conversion, okay? The word kilometer, kilogram, right? Kilo means 1,000. So there are 1,000 meters in a kilometer. Centi comes from the word cent, okay, which is 100%. You remember the word percent, right? Cent means 100. So in 1 meter, there are 100 centimeters. And each centimeter is subdivided into 10 millimeters, right? So that is the unit conversion. Milli also means 1,000th. Okay, so a millimeter is 1,000th of a meter. Let's try the very first one. Now, you might find my method a little tedious, okay? But stay with me. The reason I'm going to not just kind of give you a quick answer, most of you will probably be doing this using mental math. The reason I'm going to be going through the step by step is so that you know how to do all kinds of conversions without getting stuck with the method, right? So 3.675 centimeters to centimeters. Line up what you know, okay? So you know that 1 meter is 100 centimeters. So that is what you know, right? 3.675. Line up the units. Okay, so 3.675. What do I mean by line up the units? So these two units should be the same. Okay, that's what I mean by line it up. I'm just going to call this X. Okay, X centimeters. Okay, because we want to find 3.675 meters in centimeters. Now, you could use a crisscross multiplication, which is nothing but setting up the ratio. Okay, so that just set up the, you can just set up the ratio by set up the ratio and then cross multiply. So X multiplied by 1 is 3.675 multiplied by 100, or X is equal to 3.675 times 100 divided by 1, which is basically, you have 2 zeros here. So you have to move this decimal place 2 times, okay? Once and twice, right? So that is 367.5 centimeters. Okay, so that is the value of X. Okay, or 3.675 meters is 367.5. Some of you don't need to do this equation setup right off the bat. You'll know that you have to multiply by 100. And if you already know that, that's good. But I think it's also important to know why you're doing it. And if the conversion gets a little more involved, you want to know the method, right? Not just kind of go by intuition or rely on some past knowledge that may or may not be complete. Okay, right. 700 millimeters to centimeters. Now, again, like I said, set up the equation. You know that 10 millimeters is equal to 1 centimeter. You have 700 millimeters is equal to how many centimeters? You can multiply it, or basically what I mean by multiplying this is setting up the ratio, and you have 10 multiplied by X is 700 multiplied by 1. So X is equal to 700 times 1 divided by 10, which is nothing but 700 divided by 10. I'm sorry if this is over explaining, but I'd rather you know how to do it properly, right? So X is 70 centimeters. basically that means 700 millimeters is the same as 70 centimeters. So that's the conversion, okay? Which most of you would have looked at, taken one look at it and said, well, I have to divide by 10. Yeah, so that's fine. Try this out. You can freeze the screen and try this out on your own. So millimeters to meters, 10 millimeters is 1 centimeter. 1 centimeter, or 100 centimeters, my bad. 100 centimeters is 1 meter. So there you have, if you wanted to write this, millimeters, so 100 centimeter multiplied by 10, okay? So that is 10 millimeters per centimeter is 1 meter. Okay, so you know what I'm doing? I'm taking this 100 centimeters, right? And writing it in terms of millimeters. So I'm basically saying for every, there are 10 millimeters per centimeter. So basically, we're going to cancel these centimeters, okay? So if you're trying to see what's going on here, we're just trying to write millimeters in terms of meter, okay? So 1,000 millimeters is 1 meter. Now that we have this conversion, okay, we can set up the equation. 1,000 millimeters is 1 meter. Line up the units, and 4,300 millimeters is how many meters? And call it X. Okay, so what again, to remind you, you have to have these lined up, okay? Only if you line them up, okay, you can set up the ratio, or you can just directly do the crisscross method. So that is 1,000 multiplied by X is 4,300 multiplied by 1, or X is equal to 4,300 multiplied by 1, that's nothing but 4,300, and then divided by 1,000. Knock the zeros out. So these two zeros and those two zeros will go away. So X is equal to 4.3 meters. So basically 4,300 millimeters, or 4,300 millimeters is 4.3 meters. Basically, that means 4,300 millimeters divided by 1,000 millimeters for every meter, okay? So basically, that's what that means. Then you just divide it out, and then you can also cancel the units, and this millimeter and that millimeter will cancel. This is 1/meter, so that becomes meters, okay? So you can also kind of make sure the units are also lining up, okay? So this is an alternate method, okay? Right, off to the next question. Try this out. Pause the screen if you want to. Try it out on your own. Okay, so basically you're trying to write it in terms of centimeters, and then you can also write it in terms of millimeters. Okay, so basically this is coming because of 100 centimeter in a meter. Okay, and this is coming because there are 10 millimeters in centimeter. Right, and so basically 1 kilometer is 1. So you have 3 zeros here, right? 3 zeros here, 2 zeros here, and 1 0 there. So that is 3 plus 2, 5 plus 1, 6. So 1 followed by 6 zeros. Okay, so here's your conversion. So now line up your conversion with your question. Okay. Set up the ratio. And therefore, from the ratio, you're going to be able to cross multiply. So 0.328 kilometers multiplied by 1 million is 1 kilometer multiplied by X. So now you're going to take these 3 zeros and you're going to move 3 decimals once, twice, thrice, okay? So that's going to be 328 multiplied by 1,000, okay? Or X is equal to, they take those 3 zeros here and tag them along right beside 328. And that's your answer. Okay, hope that was easy. So that completes the second learning goal, unit conversion using the SI system. Make sure you try your homework out for this, okay? We are going into the third learning goal, parameter of 2D shapes. So to find the parameter of 2D shapes, we first of all need to recognize a few shapes. Can you pause and match the shapes? Okay, parallelogram, rhombus, trapezoid, which is also called trapezium, depending on whether you're using British English or US English, or North American English for that matter. So trapezoid, there's also something called an isosceles trapezoid. An isosceles trapezoid is basically a trapezoid where two lines are parallel and the opposite sides or the non-parallel sides are equal. So if this side is equal to this side, then it becomes isosceles trapezoid, okay? Right, rectangle, oh, we know that. And diagonal, if you join opposite ends, that's a diagonal. Right, and you have a midpoint. So this is a midpoint. It breaks a segment into two equal bits or equal halves. And isosceles triangle. So this is an isosceles. And this is an equilateral triangle. All three sides are equal. Okay, so just basically some vocabulary there for you. Some simple formulae here, formulae. If that's L, then parameter is L. There are 4 of those. So for L, rectangle, if this is L and this is W, then that is parameter is 2L plus 2W, which is the same as twice of L plus W. Okay, so that is the second one. Parameter of a triangle, pretty much add all the 3 sides. For a circle, it's either 2 pi r or pi multiplied by d. 2 pi r is basically 2 multiplied by r multiplied by pi, and that twice of r is nothing but the diameter, okay? So that is the circumference. Feel free to pause this video and try this out. So we have 5 squares here, right? So here's 1 square, 2 squares, 3 squares, 4 squares, and 5 squares. So you have 5 squares there. And this side is 6. So if this is 6, so that's 6, 6, and 6, so on and so forth, okay? So these are all 6. We want to find the perimeter of these. So if this is a square, then this has got to be 90 degrees. And then this is also got to be 90. So automatically, these two are also going to be, this is also going to be 90. So this is going to be 90. Therefore, because this angle is 90, okay, because this angle is 90, this one happens to be quarter of a circle. Okay, so from here to here is quarter okay, I hope that makes sense. I'll try to visualize it as well. Let's say I have a circle here, right? And that happens to be 1/4 of a circle. Okay, so that would be 1/4. Okay, so basically, the radius of the circle would also be 6, because this side and this side would be equal, right? So the radius is also 6. Now, if you wanted to find the perimeter, there are 6 of these fellas here, okay? Sorry, 4 of these, 2, 3, and 4. Okay, so I'm going to say 4 multiplied by 6, right? So perimeter is 4 multiplied by 6. Sorry, it's me trying to color code it for you. So 4 multiplied by 6, so that is these 4 parts, okay? That's 6 and 6 and 6 and 6. Plus, okay, 4 multiplied by how many quarter circles? 4 quarter circles. So 2 pi r divided by 4. Okay, so basically there are 2 of these, right? So we're going to add these 2. Okay, so that is the circles. These are the quarter circles. So that, and that. Okay, so that becomes 4 quarters of a circle, right? So that is 24 plus, clearly this will cancel. And you'll be left with 2 multiplied by pi multiplied by 6, because that's the radius, right? So 24 plus 12 pi, put that into your calculator. You're going to end up with 61.69911 something. Okay, so just going to write it as perimeter is 61.70 if I wanted to write it in terms of 4 significant figures. And that would be centimeters. Any questions? Well, I cannot hear you. Let's try this. Again, pause the video and try it out. So I'm going to try to color code it as usual. This part, let's try to do this part. We call this X. Okay, so if you look at this, this is a hypotenuse. Okay, so X squared plus 3 squared is equal to 5 squared. X squared is 25, take away 9. X squared is 16, x is equal to 4. So that is for this triangle. Now, if we look at this part here, that is a semicircle, okay? Kind of looks like a lopsided cone, the whole diagram. All right, so that is 3 centimeters. And now you can just assemble everything. You can say the perimeter. Perimeter is 4 plus 5 plus half a circle, which is nothing but 2 pi r divided by 2. Okay, so again, you can cancel these terms. This 2 and this 2 can cancel. Sorry, there we go. Right, and then you're left with perimeter is 9 plus pi multiplied by 1.5. Why 1.5? Because that is the radius. Okay, so this radius r is 1.5. Yeah. Put that into your calculator. You should get 13.71 centimeters. 4 significant figures. That's not the exact value. Okay. So that, oh no, before we conclude the lesson, have a think. What's the difference between a square and a rhombus? A square has all 4 equal sides and all interior angles, and each interior angle is 90 degrees. In a rhombus, we know that all 4 sides are equal, but there are 2 equal acute angles and 2 equal obtuse angles. Think about the other ones as well. With that, we conclude today's lesson. Your homework is on the unit outline. There's also formula conversion, which is linked to the unit outline. There's essential, optional, easy, and there's an extra handout. Additional practice. If you're done with all these, ask me and I'll give and I'll post it. All right. Thank you. Thanks for watching. Bye-bye.